Okay guys, so yesterday we looked at how to solve quadratic equations by square root method. So we're going to start the process of solving by factoring, which is going to be probably the most popular way we solve this semester. Popular meaning most common, not necessarily the favorite method of everybody. But we're going to start by remembering multiplication, because multiplication has a lot to do with factoring. So real quick, when you have a monomial, you distribute it. So we would get 8x squared minus 6x. So that's the distribution process to multiply. Over here on B, we take the first x and distribute it. So we get x squared plus 2x. Now on the green problem, over here, there were no like terms, so there was nothing to add and subtract together. Over here on the blue problem, however, we have 5 times x, which will be 5x, and now we will have something to combine like terms eventually. Finishing up the multiplication with a 10, we can finish this entire problem through simplification. So x plus 10. So that's how to multiply. So we're going to start factoring by remembering how to multiply. Now, keep this in mind. Factoring undoes multiplication. So therefore, factoring is a way to divide the problem apart. So we're going to start off by looking at the greatest common factor. Now this is an Algebra 1 topic, so hopefully this is something that we all remember and we don't have to spend a ton of time on. But we do need to go back over it. So we will. Greatest common factor, otherwise known as the GCF. When we do so, we are looking for the largest number that divides into each coefficient, as well as the smallest exponent of common variables. And our answer will look like this. It'll have the GCF out in front of a parenthesis, which would be a quotient. Now, if you remember what I was just saying back on this previous screen, factoring is division. Okay? Division. So that's where the word quotient comes from, because we're going to divide the problem by the by the greatest common factor. So the process of factoring is the reverse process of distribution, which is the division that I was talking about. So if distribution is multiplication, then division must be factored. The goal is to write the expression that is equivalent to the original by dividing and undistributing any common factor. So every single problem, not just GCF problems, but every single problem we ever factor should begin by looking for a greatest common factor in GCF. So, attempting to try to keep as much on the screen as possible, we are looking for the largest number, so we're right here. We're looking for the largest number that divides into 2 and 8. Okay? So what's the largest number that divides into 2? Well, that would be 2. So, 2. Okay? And so do they both have an x? Yes, they both have an x, so they have that in common. Now that they have a variable in common, what is the smallest exponent of those common variables? So we have an exponent of 2, and we have an exponent of 1. So the smallest of those is 1. You don't have to put that 1 there, but I'll put it there just to emphasize that it is smaller than a 2. Alright, clean this up just a little bit. And now we do a quotient. Now, I said that we're doing division. So we're going to create a quotient by dividing by the greatest common factor. And that answer goes in here and becomes what's inside the parentheses. So we divide. 2 divided by 2, that is 1. X squared divided by x. Division of variables means you subtract the exponent. So that's x to the first. So that finishes off the 2x squared divided by 2x plus. Now we'll do this division. 8 divided by 2 is 4. X divided by x. If you have an x and you take that x away by division, you have no more x's, and that becomes the answer to that GCF factor. Now, clean this up again. The whole idea here was to create a multiplication problem. So this is our checking. If I take 2x and I multiply it by 1x, I get 2x squared, which is exactly what we started with. If I take the 2x and I multiply it by the 4, I get 8x, which is exactly what we started with. So that's just a check. That's not the answer. Our answer is in purple. Two x, parentheses, x plus 4. So that is our GCF factoring for that problem. All right, let's quickly do B. What's the largest number that divides into 15 and 35? So we get 5. Do they have a variable in common? Yes, they do. What is the smallest exponent of those? It is 1. Divide. 15x squared divided by 5x would be 3x. Subtract. 35x divided by 5x is 7. And that is GCF factoring. Okay, so let's get to the trinomials. So a trinomial is something that has 3 terms. So, so something like x squared plus 7x plus 10. We saw this when we were doing the basic multiplication at the beginning of the problem, at the beginning of the lesson. So a trinomial has 3 terms. 1, 2, 3. This is known as the first term, otherwise known as the leading coefficient, or what's called first term. First term. This is the second term. This is the third term. And so our goal is to multiply to get the third term. So we're trying to multiply to get 10. So things like 1 times 10, 2 times 5. Both of those, 1 times 10 and 2 times 5, both multiply to give you 10. So again, this is an Algebra 1 topic that you should already know how to do, so this should be a reminder. We're trying at this point to add to get the second term. So we're trying to add to get 7. So we look at the 2 options. 1 plus 10, that's 11. 2 plus 5, that's 7. So the option that's going to work best for us would be 2 and 5. The signs in the problem are going to help us get the signs in the answer. Okay? So if the second sign, that would be this plus sign. Let's get a highlighter. The second sign in the problem tells you that the answer is going to have the same sign or a different sign. If the second sign is positive, so like this plus here, that means that you'll have either a plus in the problem or you'll have a minus in the problem. Scoot down a little bit. If you have different signs in the problem, in the second sign, then that tells you you're going to have different signs. That one of the parentheses will be plus, and one of the parentheses will be minus. So, let's get into doing some factors. Again, 100% review from Algebra 1. Might have been a little bit since you've seen it, but you should still know what to do. If trinomial is quadratic expression in the form, in the standard form, which is ax squared plus bx plus c, and a equals 1. So these are what we call the easy trinomials. So up at the top of this, you saw the word easy right here. This is what makes them easy. You're finding two factors of which, okay, of the third term, two factors of the third term, okay, or c, which have a sum to equal the b, which is exactly what I was telling you above, that we're trying to multiply to get the third term, multiply right here to get the third term, and add right here sum to be the second term, okay? So that's exactly what that little phrase just said. And then you put your answers in binomial products. So, for this problem A, we can start off by using x in each part of the front parentheses. We are also going to know, I don't like that word. X times x will give you x squared. We also know, based on the signs in the problem, that they're going to be the same. And everything in this problem is positive, so therefore, the signs in this problem are both going to be plus. And so now, we just have to look at the numbers. So what are some factors of 12? We got 1 times 12, 2 times 6, 3 times 4. And one of these is going to add up to be 7. So 3 plus 4 is 7. This is 8, and this is 13. So the two factors, 3 and 4, are going to be the numbers that enter your answer, 3 and 4, to give you your binomial product. So that's the factorization. For problem number, or example A. So something very similar in the B problem. The parentheses. We started off by using x and x. We see that the sign is positive, which tells us they're both going to be negative. Now there aren't too many factors of 25. So you got 1 times 25. You got 5 times 5. So which one of those adds up to be 10? That would be 5 and 5. So you get a 5 in here, 5 in there. And there's your product. There's your factorization of problem B. When we get to problem C and D, the first thing we're supposed to check for every single problem is, does it have a greatest common factor? Yes, it does. So this problem has a GCF of 2. So we need to remove the 2 from each term in the trinomial. So give us x squared plus 2x minus 35. The 2 continues to stay in the problem. And then we factor the trinomial. X. The sign of the problem tells us that the signs are going to be different. And what you will hear me in class say is it doesn't matter which parentheses gets the plus and gets the minus. But what does matter are the numbers. The numbers have to have the correct sign. So when you start looking at the factors of 35, you'll probably realize that 7 times 5 becomes your factors that multiply to give you 35. And will have a difference of 2. Now, the larger number, that will be the 7, is going to carry the sign. So the sign here is plus. So that means the larger value, 7, is going to be the positive, and 5 will be the negative. And one more. D also has a GCF of 5. X squared. So all I'm doing right now is removing the greatest common factor. 225 divided by 5 is 45. Okay. 5 stays in the problem. X in each front part of the parentheses. The second sign is negative, which tells you the signs are different. So what multiplies to give you 45? 9 times 5 gives you 45 and has a difference of 4. The larger number carries the sign. The sign here is subtract. So the 9 is the larger number. And there's your factorization of D.